I'm going to continue with our thread inspection discussion, and now we're going to take a look at the pitch micrometer. I happen to have an interchangeable anvil style pitch micrometer, but many of the other styles look like you see here. And what's nice about these is they can take a direct measurement of pitch diameter, so you can load your thread into the pitch micrometer and take a reading and get a direct reading without any sort of offset like we had with the wires. So there are angled anvils in here that allow for the 60 degree thread to sit inside the anvils and take a measurement. They are limited by size and by pitch usually, so if you don't have the interchangeable style like I have today, your pitch is gonna, each one of these anvils is going to be limited to a 7 to 9 pitch, 10 to 13 pitch, 14 to 18, 20 to 24, etc. And you're limited by size, so go from 0 to 1, 1 to 2, 2 to 3. If you're going to want to cover every single size and every single range, you're going to need a lot of micrometers. Or your other option is to buy the interchangeable anvil style, which I'll show you in a minute or so. When you do get larger than a 0 to 1 pitch mic, it's going to come with a standard, like you see here. And this standard will help you set 0. For the 0 to 1 mic, you can close it and check for 0, like a standard micrometer. And if you want to check against a known and calibrated plug gauge, that's one way you can verify everything is correct. So let's take a look at this micrometer that I'm actually working with. So it has a set of interchangeable anvils, so I can handle all the different pitches with just one size of micrometer. And it's a little bit more economical that way. You don't have to buy as many micrometers. Not quite as accurate, to be honest. It really depends on the maker and the manufacturer's specs, but the interchangeable part of it tends to add a little error. I'll try to show you what these interchangeable anvils look like if I zoom in on one. So let's try to zoom in. You see that size, 64 to 48 pitch. So 48 to 64 pitch on the right side, and it also has a metric pitch, 0.5 to 0.5 to 4. No, I can't. Let me actually read it. 0.4 to 0.5. So a very small pitch, and then we can go larger. See if the camera will, there we go. What is this? Should have read it first. 5 to 8 threads per inch. So you can use this anvil for anything between 5 and 8 threads per inch. Or metric, looks like 3.5 to 5. You'll notice this one's got a big blunt nose for a coarse thread, and the mating part that it's going to close onto also has a big blunt nose. And then when you talk about a finer pitch, you get a sharper nose and a much finer point. You can't even really see it. So that's why these anvils need to be changed, and why you might need so many micrometers if you're working with a standard micrometer that doesn't have these interchangeable anvils. So, how does this work? You take your external thread, you register it on your bottom anvil, and then you bring in your top anvil slowly, you close it, and then you take your reading. This is an approximation of basically what's going on, and one of the really hard parts working with these threads, I'll demonstrate now. One of the really hard parts, especially with fine threads, when you drop on your thread on the lower anvil and you try to bring in your top one, if you're crooked, you'll actually fall into the wrong thread, and you'll start to feel a resistance, and you'll think, oh yeah, I'm done measuring, but you've actually fallen into the wrong one out of line. So that's one of the hard parts with a finer pitch, say around 32 or 40. 28 even can be hard. With a coarser thread, like 16 that I have here, it's not as big of an issue. It's a little easier to see right away whether you're in line or not. But keep that in mind, when you're working with a fine pitch, it helps to check a thread, roll it over, check another thread. So roll it over, check another thread, roll it over if you can't see which one it is visually. So whichever one ends up being smallest is going to be right. Now the way we're gonna check this, I'm gonna verify 0 just like I do with a standard micrometer. So let's see if I'm zeroed out. Be very gentle, very damaged. All right, I'm a little bit off. If you can see, come on, camera. I believe it's trying to zoom in on the granite. So I'm going to cover up the granite. There you go. I'm a little bit off 0. And if we take a look, we do have the adjustment knob back here. And it did come with an adjustment wrench. And we can adjust our 0. Our other option is we can kind of loosen it and tighten it back down to get to 0. I'm going to try that. I'm going to, because the way we change out these anvils is we can unlock it and slide it in and out and then lock it into place. So I've already got it locked into place. I'm going to do all my measurements first, and then I'll show you how to change anvils. So I'm going to give it a little bit of a calibration attempt and just try to adjust it a slight. Oh, I think I went too far. So just like with an OD mic, yeah, I went too far. So I need to go the other direction. Let's check it again. Didn't go far enough. So if you watch me calibrate an OD micrometer, it's the exact same approach. All right, I'm a little bit too far. I don't like to calibrate with the anvils closed because I'm worried about damaging it. So we're gonna just, that might have been too much. I'm gonna chase my tail for a little bit longer, and then if I don't end up getting it right, we're gonna re-zero it the easier way. That might be good. Oh, gotta go a little bit more. Just a tiny bit more. I feel like I'm getting a hang for this one now. All right. There we go. I feel like that's a good 0. So next up, I got my 0. I've got a plug gauge that I know is set for 334.4. So I'm going to check that before I measure my thread. So how we do that is I've got the crest engaged inside our anvil there. See a little tiny bit of light, and then I'm going to bring our other anvil into the root until it engages with the pitch diameter, and I'm going to rock it and slowly bring it in, and it feels pretty snug right now when you can just barely rock it through. And we'll take our reading. So I'm supposed to be at 3344, and I would say I'm right about there. Sorry, let me put that on camera. I would say I'm about 3342 or 33343. I don't have that extra scale, but I'm in pretty good shape. I'm in pretty good calibration condition right now. So now I can measure my part. So I've got a 3/8 part, so it's going to end up being pretty close. To where I was before, but I still do that rock it in and out, and I try to feel for that micrometer. And sometimes it helps to open and rock, and sometimes it helps to close. So how you want to handle it is up to you. Try to just get that feel. I feel like this is pretty good. I can just barely get it through. And what's our reading? 325 plus about 2 thousandths and 3 tenths, so I would say 0.327 and 2 tenths. If you remember from our wiring, we got about 0.3263, so we're close. Again, completely different approaches. Even with the best technique, they don't always match up. It's a little bit difficult for me to do it on camera, and you saw me struggling with the wires, so there may have been some error there. But generally speaking, if you get within 1,000th or 2,000ths, that is typical. So if you're using different methods and you're getting wildly different, then there's something wrong. And try to get in the habit. I checked about here on the length. I'm going to check further down the thread and look for a taper or look for another issue. And just rock it through. Feels pretty good like that. Oh, you know what? I either have a different pitch diameter there, a little smaller, or I just didn't do it right. So let's check it again. Yeah, it seems like the thread is a little bit smaller on the backside, and how that figures into a bolt parameters, I'm not exactly sure, but I feel like I'm using the pitch micrometer correctly. If you saw this on your part, you have a tolerance for pitch diameter. We've seen in the how do I say? We have seen with the charts that we've had in previous slides. So you do have a tolerance. Let's review that real quick. You do have we have about 5 thousandths of window, 5.5 thousandths of window in that red box, or sorry, 4.5. So you do have a little bit of tolerance if you measure two different readings. Now, what's similar to a pitch mic is you can convert an OD mic into a pitch mic with these attachments here. So you can buy a little ring that will slide onto each anvil, and then that ring will also hold onto a similar style anvil that I had for this pitch mic that I showed you. And that will add some thickness to your OD micrometer, so it will no longer be a direct reading. But typically, you just have to subtract whatever thickness was added, and that is controlled by the manufacturer. They'll be able to tell you. It's usually a very simple subtraction. Same thing for calipers. If you want to work with a caliper, there are caliper attachments that you can put onto your caliper and then add these thread anvils. Now I want to say definitely with the caliper, this has got to be for reference only. There's really no reasonable way to do this accurately. I would say if you are going to be using a calipers, if you can measure something that you know it has a certain pitch diameter before you measure your part, that's one way to kind of be a sanity check. With the OD mics, it's a little bit more stable. You're using an OD mic, and we often attach things to OD mic to give them different shaped anvils. So I trust that a little bit more, but with the caliper, it's nice because you can do external or internal threads with the caliper, because you can get these attachments can be for internal thread or external thread, which is cool. I like using them, but I use them for reference only. So just keep that in mind. There's more options out there if you want to research and look up if you got some challenging thread issues for your inspections. There are many more tools. I'm only going over the most common ones, but there's thread rollers. There's real advanced sort of 3-foot kind of like a whole micrometer, has 3 foot spring extension that will go into your hole or around your shaft and tell you. There's light based, there's CMM based, there's a lot of other ones. So me going over the most common ones, and this is one of the ones I wanted to highlight. It's not too expensive, and it's pretty useful if you want a quick check. Next up, we're gonna work with the. Oh, you know what? Before we go ahead, I promised I'd show you how to change anvils on the standard pitch micrometer that I have here. So it's fairly simple. As I said, I closed it and it was 0 the way I had it calibrated. So it's still on 0. Now if I want to change the anvils, I'm going to unlock this. And for the back side, just wiggle it out. There we go. Got that one out. And come on, little buddy. Got that one out. So it's a pretty tight fit, little vacuum effect, but you can pull these out and slide in another one. So I'm gonna put them back because I'm gonna keep using that external thread. So I'm just gonna load it back in, clamp that down, and load this one back in, clamp that down. And now when I go to 0 it, it's probably not going to read 0 anymore. If you saw how much, how far that moved to come out. Look, I'm at 0 on this side, and I'm not even close here. So what I'm going to do is I'm going to lock this down at 0. Okay, I'm going to unclamp this, slide the anvil in. So this is like I said, the easier way to calibrate. And now when I close it, it's 0. And it's closed, and I'm ready to go. So one style of micrometer. There's other interchangeable styles, and of course there's solid micrometers where you can't even change the style or change the anvils. So, but pretty nifty tool. You get to do a lot of different pitches with just one tool. All right. We're going to move on to the leaf gauge, which most people are familiar with. It's kind of a reference gauge, but in a pinch, if you had nothing else, you didn't have rings, you didn't have wires, you don't know what pitch you're working with, right? Sometimes you get a part, you don't know what pitch it is, you don't know which wires to grab, you don't know which pitch mic to grab, you need to identify it. Well, you can use the leaf gauge and give it a nice profile check. So you'll hold up the gauge into the leaf and check for a profile. It's pretty much guess and check, when you have all those options and you fan them out. But it's not too bad. Generally speaking, I'll eyeball what I think looks closest, then I'll know right away whether I need to go lower pitch or higher pitch. So let's show you how that looks like on this bolt. I already found the 16 pitch to save time, but if I tried a bunch of other ones, I'll fan them out. Let's say maybe I thought it was a 13 pitch to start off with, and you try to hold it up. Let me get a white background so you can see a little easier. I try to hold it up and you still see quite a bit of light there. It doesn't want to match. So we'll try the 18. Yeah, this is the 18. and you'll see I've gone a little too far. So I need to find the 16 and show you what it looks like when it's just right, just like Goldilocks. All right, so when we have a 16 and a 16 pitch, it'll fit right in there perfectly snug. So these gauges have a certain length to them, and you should try to use the entire length. There are sometimes cases with coarser threads or finer threads actually. With finer threads, you know, the difference between like a 40 and a 44 may be really hard to tell without using all of your engagement. So try to use all of the gauge and not just hanging off on a few. We have another couple that I'll try to identify, and I know these are metric, and that's about as much as I know. So I'm going to eyeball what I think it looks like. Oh, got the wrong set. Here's the metric set. So maybe it looks close to that. No, I can't quite get that to go in. So let's try a smaller one. Let's try 1.5. Oh, hey, 1.5 looks pretty good. So my second guess was right. Can't see any light. Just for verification, I'll go to 1.25. And it's close. It's definitely close. But I cannot get it to go in. Yeah, it's pretty blurry. Can't get it to go in. So I'll show you the 1.5 again, which looks good. No light. Oops. No light. So that's how you use it. Just helps you identify your gauge or your thread, and occasionally if you think there's something wrong, you can see it right away with one of these gauges. You know, you'll see something wrong with the crest or the root. They make versions of this for identifying gears as well. So gears are very much like threads in that they have a profile, and you just need to make sure, you know, it'll help you identify the profile of the gear. Now we're going to take a little aside. When you need to measure the depth of a threaded hole, you know, we could talk about this in the hole inspection topic or the thread inspection topic. We're going to talk about it here since we are talking about threads. What you end up doing to get the depth of the hole, you know, sometimes the depth might be, it needs to be 1 inch down or a 1/2 inch down. And you need to measure how far it went. You don't, you know, it can't be shallow and it can't be too deep. Generally speaking, you have 1 or 2 turns or like a 64th. I can't remember. I could look at our drawing. Yeah, 16th. That makes more sense. You might have a 16th of tolerance. Generally speaking, you don't want, if it's a blind hole, you don't want it to poke through into another feature. But for assembly purposes, you're generally a pretty open tolerance. But as you can see on this bolt, I had to modify it. So I ground the lead in off. So bolts usually have, you know, around, this is back. Bolts usually have that round lead in, and I've ground it off so that it's perfectly flat, and I can really know exactly where the thread stopped. I also ground off the bolt head, because this bolt happened to have a bunch of markings for identifying the bolt from the manufacturer, and they weren't allowing me to sit flat or to measure a caliper across it. So I just ground those off. With a cap head screw, they generally sit pretty flat. All the markings are below, so you may want to grab one of those if you can. But how we how we use this ground flat bolt on both sides to measure the depth of a hole. Essentially, we're gonna zero our micrometer on the overall length. We're gonna thread the hole in, and then we're gonna take a reading with our depth bar. And doing it this way will give us a direct reading of the depth. So let's do that with our angle block. Here's our angle block. So first of all, I'm going to zero on the length of my bolt. Okay, zero on the overall length. I'm going to thread into the hole, and this is supposed to be a through hole. However, the manufacturing process seems to have left a burr because I can no longer easily thread that in, and it still hasn't poked through. So we're going to see how far it went before the burr stopped it. I'm going to grab our caliper, and now I'm going to bring it down, and it's down at a depth of 0.929. So because I zeroed on the length of the bolt, and I'm measuring the piece that is missing, basically, it's basically telling me the piece that's missing, not the piece I'm measuring, because I'm not zeroing when it's closed. I was zeroing it on the length. Oh, sorry, I'm not zeroing it. I'm zeroing it on the length, about here. So it's telling me what piece is missing, and that missing piece is inside the part. I'm not zeroing it when it's closed. So it's a little trick. It's pretty handy. Your other option is to zero it when it's closed, and I'll do that as well. Why not? So I'll zero this while it's closed, and we'll see how much is sticking out, like a typical measurement. 1.197. And then we'll subtract the length of the bolt. Which is about 2.131. 0.934. So if I do it the method that I was talking about, where you zero it, and thread it in, .930. So slight difference. I did move the thread. I moved the bolt. It may not have registered exactly the same. Thread assembly is not a precision assembly in most cases, so I'm not surprised I got a little bit of a difference, but that's two different ways you can do it. Oops. All right. We're almost wrapped up. And I'm going to give you a quick reminder, as a reference tool, a bucket of bolts and nuts, if you know what they are on the shop floor, that can help you, quickly tell if the bolt is going into the hole, if it's the right pitch. If the bolt doesn't go in, odds are it's out of spec already. So a lot of people will keep these around and use these as in-process gauges, and then when they're finished with their hole, they'll check it with a practical thread gauge. Same thing with a nut. It's very cheap to get these. It's very expensive to get the ring gauges. So they might be checking with a nut for a while and then use the ring gauge as needed. It's something to be aware of. It's not precision. It's not traceable. It's not something you can put on an inspection report, but it is something you should keep available to you as needed. And then we're going to wrap up with a quick bolt and nut identification reminder. So if you need to identify a bolt, in order to identify a bolt, you're gonna do the major diameter with a caliper. So this major diameter is 0.366, 0.367, and you're going to have to round that to the nearest fraction. So 367 is pretty close to 375, and in the world of finite bolt sizes, it's a 3/8. For the leaf gauge, you're gonna use that to measure the pitch. So we already measured the pitch of the bolt. You can use the same thing on a nut if you don't know what pitch it is. You can use the leaf gauges internally. It's a little harder to see, obviously. And then for the length for the bolt, you're gonna take the length of the bolt without the head. So I'm reading 1.945, and again, you have limited bolt sizes. I would say that's about a 2-inch bolt. So the trick for that is don't involve the head at all. All we care about is the length of the shaft. For the nut, it's pretty much the same, except for, you're going to caliper the nut thickness for the length, 0.328. I might also round that up to 375, which is 3/8, because of the finite number of bolts that are available. But the key here is the nut major diameter. You can't measure the major diameter of a nut. The major diameter is on the inside of the material. You can't get anything there. So in order to identify the major diameter, you're basically just going to find the bolt that goes on, and you call that a 3/8 nut because a 3/8 bolt went on it. That's also a quick way to identify the pitch as well if you already know the bolt and the nut. So a number of, it's tricky at first when you need to identify maybe you need to identify a nut or a bolt that you have in the shop to get a replacement, and you want to order the right thing. So just a quick reminder. And then we're gonna close up with MPT, a quick discussion on MPT threads. MPT threads are tapered. So when a tapered thread, the male and female taper go into each other, they always stop because the way the taper is set up. So it's a great for sealing, with a liquid or a gas. You're probably going to need a thread tape anyway to help seal it, but it's much better than a parallel thread, a straight thread. You can't really seal with those. But when you're using a plug gauge and a ring gauge, because these threads are tapered, standard plugs and standard rings no longer apply. You're going to have a tapered plug and a tapered ring, and each one of those gauges on the plug side is going to have a flat. And if you pretend that this is a tapered plug gauge, this one has a flat for other purposes, but when you are cutting your thread, you're looking for the flat to be close to the surface. And generally speaking, you have one full turn plus or one full turn minus. Sometimes you have less than that, so you have to maybe get an indicator out and run an indicator across the flat and across the top. But most of the time, MPT threads are kind of open tolerance, and so you're given a full turn plus or minus is a pretty big tolerance for a lot of MPT threads. Same thing for a ring gauge, but instead of having a cutout, you're just looking for for the thread to be flush with this surface on the top. So if you were to pretend, I wish I had a gauge to show you, but if you were to pretend that this nut were an MPT gauge, you're looking for the the finished part and the gauge to end up flush. Clear this out. Okay, so you're looking for a flush, not sticking out and not too deep, but within a turn plus or minus, or whatever tolerance that the print requires. Sometimes it's less than that. All right, so sorry about these technical issues with presentation. I guess that's it. So I want to thank you guys for watching. I appreciate you taking the time. I hope you learned something about inspecting threads, about using thread wires and pitch micrometers and go and no-go gauges. I struggled a lot with the thread wires. It's not unusual for people to do that, so keep practicing. Practice on diameters that like plug gauges, calibrated plug gauges, finished parts that you have ring gauges for, and same thing with pitch micrometer. Practice a lot, and you guys you'll get the hang of it. Please check out the website pragmaticmetrology.com for more of these videos on gauges and on concepts that will help you make decisions as inspectors and machinists who are working with gauges. And I want to thank Laney College. Let me use this part as a demo piece. The Laney Machine Technology Department in Oakland, California. They have a great department there. A lot of course offerings to students in manual machining, CNC machining, metrology, of course, CAD design, blueprint reading, pump maintenance. They offer a lot to the students there. They have certificates you can earn, associate's degrees, and they even work with apprenticeship programs, so you can get your apprenticeship hours and classes done there. So I want to thank them, and I want to thank you guys for watching, and I hope you enjoyed it, and I hope you'll check out my other videos. Thanks.